Hi everyone. Today we are going to discuss two past paper questions which are relevant to the vectors. The question number one I scrapped. It was from 2023 paper, and second question, this one is the first question of 2021 paper. Both are extended Cambridge 625 paper, right? Okay, let's move to the first question. A boat crosses a river. The boat points at right angles to the river bank and it travels at a speed of 3.5 meters per second relative to the water. The river current acts at right angles to the direction the boat points. The river current has a speed of 2.5 meters per second. Let me underline the details. By drawing a scale diagram or by calculation, determine the speed and direction of the boat relative to the river bank. Right. So guys, I am suggesting you to go a small like a sketch, so then you can easily identify the description. So suppose that this is a river which flow from A to B, right? Water flow from A to B. Then the speed of the water flow is given, the river current. It has 2.5 meters per second. So it flows 2.5 meters per second, the speed of the river current. And the boat, there's a boat like this, right? This boat is trying to cross the river. So it's moving perpendicular, right angle, perpendicular to the river current, right? Then there are two variables, two speed quantities acting on the boat, right? This one is the speed of the boat 3.5, right? And this one is the speed of the river current 2.5. So you can use either scale diagram or you can do the calculations. If you use the calculations, let me erase this part. You have to use the tan theta. Tan theta. Draw the triangle. This is 2.5, right? One is 2.5, one is 3.5, and you have to find out the angle. Theta. Theta equals 3.5 divided by 2.5. Sorry, opposite. 2.5 divided by 3.5. This is tan theta, right? Tan theta equals, you can do the calculation. Or else, you can draw a scale diagram. Scale diagram. Let's try the scale diagram. I want to show you the scale diagram, how to draw it. So I'm using the Microsoft OneNote, the ruler. Guys, I'm using green color for the boat's speed. Boat's speed, right? So it's 3.5. So let's use 1 centimeter equals 1 meter per second, right? 1 centimeter is equal to 1 meter per second. Then the speed of the boat is 3.5 meters per second. So the length of the speed vector, the speed of the boat should be 1, 2, 3 and 3.5. And for the boat, it clearly mentioned that uh, both speeds are perpendicular to each other, so right angle. I'm using red color for the speed of the river current, that is 2.5 meters per second. So our scale is 1 centimeter per 1 meters per second. So it should be this much, this much. If you draw like this, incorrect, because when you try to find out the resultant force or resultant vector, the tail of the second arrow should be the head of the first one. So 2.5 we should be start here, 1, 2.5. Now it's okay, right? Then the resultant speed would be given in this one. Right? Right. Length of this line arrow is 1, 2, 3, 4, 4.5, 4.6 maybe, 4.6. Let's say 4.6. Right. And the direction you have to write relative to the river bank. That means from the horizontal surface. From horizontal surface, how many degrees? You can see 53 degrees. 3 degrees from the horizontal surface. It might be 54, 56, 54 or 56. Right? The speed is nearly 4.6 meters per second, and the direction of the river bank is nearly 54 degrees. 54 degrees. You have to do accurate diagrams. I just wanted to show you the method. If not, if you are not drawing the diagram, you can use the calculation. Tan theta equals before we move to the tan theta, let's draw the triangle. This direction, river current, it's 2.5, and here it's 3.5. 3.5. Tan theta equals 2.5 divided by 3.5. Theta equals tan inverse 2.5 divided by 3.5. 2.5 divided by 3.5. Right. Part B. You know the ruler. Speed is a scalar quantity and velocity is a vector quantity. State the names of one other scalar quantity and one other vector quantity. Scalar quantities: volume, mass, length. So variables which have only a scale, like only the size. There is no direction of acting. There is no direction of exerting. So these variables, they don't have in direction of exerting, direction of acting, so they have named as scalar quantities. Vector quantities: variables which have magnitude plus direction, magnitude and direction. Examples: you can write velocity, acceleration, force, momentum. Right? Here speed also a vector, scalar quantity speed. Right. That's it. Simple question. Question number 2. This is from 2021, extended. The season is November, October, November season. October, November season. Right. Some physical quantities are scalars and other physical quantities are vectors. State how a vector quantity differ from scalar quantity. The difference is vector quantities have a direction of acting, or direction of exerting. Circle the vector quantities in the list. Acceleration, change in velocity divided by time. So velocity is a vector, so acceleration is a vector. Energy is a scalar quantity, mass also a scalar quantity. Momentum, velocity times mass. Velocity is a vector, so momentum is a vector. Temperature is a scalar, time scalar, speed also scalar. Velocity is a vector. Question number 1, part C. A microphone in a recording studio has a mass of 0.55 and weight is W. Calculate W. W equals mass times gravitational acceleration. Mass is 0.55 kilograms. Gravitational acceleration 9.8 meters per square second. So 5.5 newtons. Part 2. The microphone is suspended from the ceiling by cord attached to a small ring. Figure 1.1 shows the microphone pulled to one side and kept stationary by horizontal thread. So you can see the cord here. There is a tension in the cord and horizontal thread. There might be a tension in this direction, and the weight of the mic would be exerted perpendicularly downward, right? And weight is equal to 5.5 newtons, right? Let's see the question. The tension T in the horizontal thread is 8.1. The tension of this thread is 8.1 newtons. Determine graphically the magnitude and the direction relative to the vertical of the resultant of W and T. Use the scale of 1 centimeter to 1 newton or greater. Right. So when there are two forces, two vectors exert perpendicularly, the resultant force should be in between this area, in between this angle. It might be here, it might be here, somewhere in this area, right? So we need to use the scale, right? Let's use a triangle method, or else you can use the parallelogram method as well, right? 1 centimeter equals 1 centimeter equals 1 Newton. So we have, if this is the ring, right, this dot, right, 5.1, 5.5, sorry, 5.5, 1, 2, 3, 4, 5 and half. 1, 2, 3, 4, 5 and half, right, this much of length. Then horizontal thread, it has 8.1 newtons. So the length of the horizontal thread, that line should be 8.1 centimeters. 8.1 centimeters. Right. 1, 2, 3, 4, 5, 6, 7, 8.1. 8.1. Right? This is 8.1, this is 5.5. Now, in the triangle method, to find out the resultant force, if you draw this 8.1 in here, it's wrong, because the tail of the second arrow should be start in the head of the first one. 1, 2, 3, 4, sorry, 1, 2, 3, 4, 5, 6, 7, 8 and half. Right? It should be like this. Then the resultant force should be given by this line. The length of this line would be given the magnitude, and by the angle you have to find out the direction. 1, 2, 3, 4, 5, 6, 7, 8, 9 and nearly 10. 10.1. Right? I got 10.1 newtons because the length is 10.1. Right? And the direction 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 of resultant. What is the direction? It's 33 relative to the horizontal surface. 33 horizontal relative to the horizontal surface. This is 33. That means this is 47. 47. Magnitude is 10.1. Magnitude of the vector, magnitude of the force is nearly 10.1. And direction of resultant, you can use like exact pencil and a ruler. The values I got in this sketch is 10.1. Right? Direction of the resultant 33 degrees from the horizontal surface, relative to the horizontal surface. Right? And if you want to find out the calculation, the answer using the calculation, it should be it should be 5.5 divided by 10.1 equals tan theta equals tan theta. Theta equals tan inverse 5.5 divided by 10.1. Okay. Just leave a comment if there's any doubt or any question. State and explain how the magnitude and the direction of the resultant C, second part, compares with the force on the ring due to the tension in the cord. Resultant force, direction of the resultant force, it was here. Right, when you draw it, you might get an vector opposite to the chord, right, opposite to the chord, and length should be 10.1. Use the ruler. But in here it's 52 from the horizontal. So the resultant force is here. In the question they ask, state and explain how the magnitude and the direction of the resultant in C second part compares with the force on the ring due to the tension in the cord. Tension in the cord here. So the mic is balanced. Mic is in equilibrium. So this resultant force and the tension of the cord must be opposite in direction and equal in magnitude, right? Otherwise the mic cannot be stay in equilibrium. These two forces must be equal. If the tension of the cord is 10 newtons left to right, there should be exactly 10 newtons right to left, right? So when you consider the point of ring here, these two forces, that means resultant force of the tension of the horizontal thread and weight of the mic, the resultant force R should be equal to the tension of the cord, right? And direction must be opposite, right? Equal in magnitude and opposite in direction. These two forces, right? That's it. So see you guys next time. Stay safe and God bless you.